Okay, this lesson is on margin of error. And we should be able to determine the margin of error for a quantitative data set or a categorical data set. Okay, so Alex makes the claim that 75% of free throws, he makes those 75% of the time. Gabriella wants some proof, so she watches Alex shoot 50 free throws. He makes 30. Gabriella calculates this to be only 60% success rate. Alex says that even though he only made 60% this time, it's still possible that he makes 75% of his free throws because this was just one sample. What do you think? Well, it is true that this could be a bad day for Alex, and it's just one sample. But it also could be true maybe his success rate is a bit lower. So how do we know what the margin of error is from a sample size? Or if it's a biggest sample size, or how do we go from there? Okay. So margin of error really indicates how much sample findings may differ from the actual population. So remember, a sample is a smaller subset, and we want to know how much it might differ. So if 40% of the people in a poll favor a new tax law, and the margin of error is plus or minus 4%, then it is likely that 36 to 44%, right? 40% plus 4 and 40% minus 4 gives us 36 to 44 of the whole population would actually favor the new tax law. So there is some formulas to be able to determine this. So margin of error, if it's a quantitative data set, right, dealing with numbers, then it's 2 times the standard deviation divided by the square root of n, and n is your sample size, excuse me. So, and remember, sigma represents population standard deviation. Okay, so 2 times the standard deviation divided by the square root of the sample size. If it's a categorical data set, then it's a little bit easier. We just take 1 divided by the square root of the sample size. Okay, so you have to determine which kind of data set it is first, and then you can apply these two formulas, and that'll tell you the margin of error. Okay, so let's take a look at an example. Lincoln High School believes that its seniors score considerably higher than the national average on the SAT, in mathematics. So the school randomly sampled scores from 200 seniors, finding a mean score of 550. The standard deviation is known to be 121. Find the margin of error and determine a range of values in which the actual SAT mean score lies. Okay, well, this is numerical data, so we know that this is a quantitative data set. So I know that my margin of error, maybe abbreviated MOE, is equal to then 2 times the standard deviation over the square root of the sample size. Okay, so in this particular case, what do I know? And I know that the standard deviation is 121. I also know that N is 200, right? They sampled 200. Okay, so those are the two things that I'm gonna plug in here. So I have 2 times 121. Let's try that again. There we go, 121 divided by the square root of 200. Okay, and I want to figure out what that is, and that's my margin of error. Okay, so I'm going to use my calculator to do that. Okay, so we're going to go 2 times 121, and we're dividing that by the square root of 200. So we get 17.11 we're going to say the nearest score since that's how SAT scores come in. So we'll say 17. Okay. So the margin of error is 17. So that is the first part of the question. So I have that already. So I'm just gonna highlight my answer there. Okay. Now it says determine the range of values in which the actual SAT mean score lies. Well, we know that it's 550. So I want to do plus or minus 17 to get the range, since my margin of error is 17. So if I add 17 to 550, I would get 567. If I go 550, minus 17, I would get 533. So my range of scores would be 533 to 567. So that would be the other part of that. Okay. Hopefully that makes sense. Okay, let's try another one. A random sample of 100 Lincoln High seniors reveals that 40% plan to take the SAT this year. Use the margin of error to predict, should be 2 there, predict the actual proportion of seniors planning to take the exam. Okay. Well, our responses to this would just be, are you planning to take the exam? It would be just yes or no. So those are categorical responses. So we want to use the other version of this, which would be this. For categorical data would be 1 over the square root of n. Okay, so in this case, n would equal 100, right? That's how many people they sampled. Okay, so this would be 1 over square root of 100. The square root of 100, you know, is 10. So this is just 0.1%, or I'm sorry, 0.1, which is the same as 10%. Okay, so the margin of error is, in this particular case, 10%, because they gave us the information in percent. So this is 10%. Okay, so then what would be the range? Well, it would be plus or minus 10%. So our poll said 40%. So what do you want to say? 40 plus or minus 10. So that would give us 50 and 30. So our range would be from 30%, I guess I should put the percent on there, to 50%. Okay, that's a categorical one. All right, let's do one more example on margin of error. This says a manufacturer of cereal boxes wants to know the mean weight of the boxes it produces. Previous studies have shown that the standard deviation of the weights of the boxes to be 0.1 ounces. They would like to estimate the mean with a margin of error no greater than 0.012. Determine the sample size needed to obtain this. Okay, so it's helpful in this situation to just kind of write out what you know. You know the standard deviation to be 0.1. We also know that the margin of error that they would like is this. Now, this is numerical data that they're collecting, the weight of boxes, right? So we know we're going to use the quantitative version of our formula. So MOE is equal to 2 times the standard deviation divided by the square root of n, the sample size. So I know a couple of things I'm going to plug in, right? I know that the margin of error is this. I know that the standard deviation is 0.1. I don't know what the sample size is, right? That's what I want to solve for. Okay, so we're going to solve this and see what we get. All right, so the first thing I would want to do is get rid of that square root of n in the denominator. So I would multiply by the square root of n and multiply by the square root of n. So these cancel out. So this on this side would be 0.2. And over here we would have square root of n times. Okay. Next, I want to isolate the square root of n. So I'm going to divide by 0.012 on both sides. So these would cancel. Okay, so 0.2 divided by 0.012, let's see what we get. Okay, so 0.2 divided by 0.012 gives us 16.6 repeating. Now I have the square root of n is equal to that. Okay, so I would want to take that squared. I want to square both sides. So what would that give us? 277.7. Okay, let's write that information on our note sheet. Okay, so this was 16.6 repeating, right? So like I said, in order to solve this, you'd want to square this to get rid of the square root. So square this. All right, so when we did that, we get n equals 277.7 repeating. So what that means is they would need to sample 278 boxes. So our answer, let's see, let's write this over here. 278 boxes would be our sample size that they would want. Okay, and that's how you use some of the information with sample size and standard deviation to find your margin of error, or vice versa, in this case, find the sample size from some other information. But this is margin of error for two different kinds of sets, quantitative and categorical. I hope that makes sense. You can go ahead and give this an assignment a try. Don't forget to write these things in your planner. Good luck.